All right, here we are. Snow day. Still have to carry on. So let's start with the bell work because I just want to refresh our memories from last week. So what is the difference between a subscript and a coefficient in a chemical formula? I need to reproduce that. All right, we've got two numbers here, this big number and this small number. Remember, the small number is the subscript, and it tells us the number of atoms. Whereas the coefficient, that's something new that we just started using on Friday. That tells us how many of a molecule we have. How many of an entire molecule, I'm going to write. That says molecule because I said it so. So what element or what compound are we looking at here? Does anybody remember? Take a moment. It looks like the word nacho, but it's spelled wrong. It has Na in it. Sodium bicarbonate. So the coefficient is telling us that we have 6 sodium bicarbonate molecules. The subscript is telling us we have 3 oxygen atoms. All right, now that we got that far, let's just review our notes quickly on balancing chemical equations. I'm going to grab my notebook here. Balancing a chemical equation, it says, number 1, we have to make an inventory of every element on both sides of the equation. So check for the same elements and check for the same number of elements on both sides, on the reactant side and on the product side. Because remember, our end goal here, and I can't see if I'm pointing in the right direction, it's on the word wall up in the corner over here. The law of conservation of mass tells us that no atoms can be created or destroyed in a chemical reaction. So the reason we balance the equation is to make sure we have the same elements and the same atoms on both sides of the chemical reaction. So step number 2, figure out which atoms or elements don't match. So if you have 4 hydrogen on the reactant side and only 2 hydrogen on the product side, that does not match. So what do you have to do? That's step number 3, the long one. It says, put coefficient in front of the compound containing the element in question on whichever side has fewer atoms. So if you have fewer hydrogen on the product side, that's where you're going to put the coefficient, right? Step number 4, redo the inventory. So you look at the whole problem again. Do you still have the same element and the same number of atoms on both sides of the equation? That brings you to step number 5. If you do, if they all match, you're done. If not, you have to go back to step 2 where you figure out which elements don't match. Ta-da! So today we were going to put that to the test in class, but we're not in class. Thankfully, what we're going to do is a computer simulation on balancing chemical equations, and you can still do that on your own. So I'm going to take you there. At least I'm going to try to take you there. Let's see. We will be going to this site, the PhET Balancing Chemical Equations site. And you may or may not have this piece of paper in front of you. This is what we are going to do in class today. We're going to do the introduction together. So let me click on the introduction here. Notice we've got 2 boxes. One box is above the reactant side here. I wonder if I can do that. Reactant side. The other is for the product side. And step 1, part 1, directions, it says choose introduction. We did that. Select make ammonia. It's selected. And then it says to open up the tools. If you open up the tools, you'll see there's a balance and there's a bar graph. I prefer the balance. If you want to try both, you can. But the balance tells us how many atoms of nitrogen, in this case, and how many atoms of hydrogen we have on both sides of the equation. Let me see if I can open this up again. Can I just want to be able to, I want a sketch pad. I don't want to sketch just the screen. I see no smart ink. All right, let's try this. So these balances right here tell us where the reactants and the products. Reactants on this side, products on this side. So in a moment here, when I go back, the reactant and product symbol I put above there is not going to be there any longer, unfortunately. But as we change the coefficients down below, the balance is going to go up and down to tell us whether or not we are following the law of conservation of mass. Let me just get out of this again. As you can see, they're gone. So I'll add a coefficient to each one of these. So it looks like now we have 2 nitrogen on the reactant side and 1 nitrogen on the product side. According to the steps, that doesn't match. I need to put a coefficient on the side that has fewer. So I have fewer on the product side. So I'm going to add the coefficient there. I've done that, and now you can see that my nitrogen atoms are balanced on both sides of the equation. Same on the reactant side as on the product side. Now let's look at the hydrogen. It says we've got 2 hydrogen on the reactant side, 6 hydrogen on the product side. So I have fewer on the reactant side. That means, according to the steps, step number 3, I need to add a coefficient to the reactant side. So I'm going to add that right there. My balance is still not even, so I still have fewer on the reactant side, so I'm going to add that again. And I get a smiley face to indicate it is balanced. So now on your sheet, what you need to do here is draw a picture of all your reactants, draw a picture of your products, and then write in the coefficient next to each of these chemical formulas. So right here I'd put 1 and 2. Here I would put 3 hydrogen. And here I would put 2 ammonia molecules, because this is an ammonia molecule. It says we're making ammonia. The product then is ammonia. Once you completed that, you can go to the next one, separate water. So here we are going to separate water. I'm going to add a coefficient to each side, see what we have. It looks like the hydrogen are already balanced, so I'm going to just focus on the oxygen. I've got 1 oxygen on the reactant side. I've got 2 oxygen on the product side, so I need to balance that. According to step 3, I need to put a coefficient on the side that has fewer, so I'm going to add the coefficient to the reactant side. I do that, my oxygen is balanced, but now my hydrogen is not. So let's look at the hydrogen. I've got 4 on the reactant side, 2 on the product side. That means I need to add a coefficient to the side that has fewer. That is the product side. I'm going to go back, add, whoops, wrong one. There we go. Smiley face, it is balanced. So on your sheet, you can draw in the molecules for the reactants and for the products. Then you can fill in the coefficient on the bottom. Combust methane then, third one. Oop, there we go. Now we have 3 elements that we're working with. I'm going to add coefficient to each of them. It looks like carbon is already balanced, so I'm not going to touch that. I'm done with that one. Let's look at the hydrogen. I've got 4 on the reactant side, I've got 2 on the product side. So I'm going to add coefficient to the side that has less, sorry, happens to be the left. Add it there. Now my carbon and my hydrogen are balanced. So now let's look at the oxygen. 2 oxygen on the reactant side, 4 on the product side. So I'm going to add coefficient to the side that has less, that's the reactant side. I do that, button, do that, and they are balanced. All right, now that we've done this using the balance, let's see if we can do it without the balance. This brings us to the side 2. So you're going to go ahead and click on the game side. Click on game and choose level 1. Now the first thing, you can see they're empty. There's no scale, so you might have to do some counting. So add coefficient 1 to each. It looks like we've got 1 carbon on the reactant side, 1 carbon on the product side. We've got